Yeah, I think so. But anyway, we talked about, on this one, if you have the point negative 2, 4, just what we talked about reviewing. 1, 2, 3, 4, negative 2, 4. I'm going to move x to the right 3 units because that's inside the function. Anything inside the function is going to affect the x's, whether it's by multiplying or by adding or subtracting. So that moves it to the left 3 units. 1, 2, 3. So I'm right here at 1, 4. Now, like we said earlier, what comes first? Multiplying by a half or adding 3 in the order of operation? Multiplying by a half, you're going to multiply the y coordinates. Anything outside the function is going to affect y. Okay? So I'm going to multiply by a half. I end up at 1, 2. And then finally, it says I have to add 3. Is that going to affect the y coordinate or the x coordinate? Y coordinate. What did I do? I took half of y. I took half of y, and then I'm going to add 3 to it. Anything outside the parentheses is going to affect the y. Anything inside the parentheses is going to affect the x. So half of y, we already did. Then I'm going to add 3. So my final answer will be the corresponding point will be 1, 5. Okay? How'd that go? Pretty good? Yep. All right. Hopefully it goes a lot better than last time. Yeah, I took this point up 3 to make it 1, 5. All right? Inside stretches it or moves it. And there's all kinds of fancy words for that. Here we go. It's actually not that bad. You know what? There's a new, I'm doing this in my classes with a lot of juniors. We're talking about how to read word problems for the ACT PSAE. Anyway, they always say in a high-stakes test, the question's at the end. They advise students in a math test to go to the end and read the question first. So, this tells you the answer. I don't see a question here, so we're in good shape. I always thought there was going to be a question, but there's not. Here we go. Explain how the graph compares to the original y equals f of x. For example, this they're modeling the answer for you. I like that. For example, the equation y equals 2x plus 3, the graph is shifted 3 units to the left and stretched vertically by a factor of 2. Vertically affects the y's. To the left affects the x's. We just talked about that. So in this example right here, which way is the graph going to be shifted? Yeah, 1 unit to the right. Don't forget, our base graph is x minus c, or d. Did I use a d earlier? D. D is the number you're moving. If d is positive, you're going to the right. If d is negative, you're going to the left. Yep. It would be. You would go up 3. So it'd be a vertical stretch, stretched vertically by a factor of 3. Okay? So that's what you write for that one. This is stretched vertically. By a factor of 3. Wow. And this one's stretched, I don't know. And the graph is shifted. Shifted to the right. 3 units. I sure as heck didn't want to write all that stuff. Oh, it is 1 unit. I was looking at the 3 in front. All right, so shift to the right 1 unit. That's a big period. Your handwriting is obviously going to go out better than that. Stretched vertically by a factor of 3. All right. See, all that words, not a big deal. Questions on that? That's like the 4th example we've had today. The second one on the mic. So on this one, is the graph going to be shifted to left or right? No. Is the graph going to be shifted or stretched? Vertically? Yeah. And remember, we said when A was, and we had A in front of the f of x, we said when A was between 1 and 0, we didn't really call it a stretch, we called it what? Started with a C, ended with an ESS? Compress. So we'd say it's being, you can say compressed, vertically compressed, by a factor of 3. So compressed already tells you it's a fraction. Or you can say vertically stretched by 1/3. You see the difference in the words and the definitions? A compression already tells you it's a fraction. The 3 tells you it's a denominator. Or you can say vertically stretched by 1/3, which means you're pushing it down. If you had a y coordinate of, say, 3, 9, on this graph, it would actually turn out to be, well, on this graph, you would have 3, 3. And if you took 1/3 of it, the new point would be 3, 1, right? And you're multiplying the y coordinate by 1/3. So far, so good? Questions on that? Outside affects the y's, inside affects the x's. Yeah. No, I said that point wouldn't actually be on the original absolute value of x. Okay, so that was a bad example. So I went from 3, 3 to 3, 1. Okay. All right, moving on. Oh, I need 20. The graph of the function with domain 0 forward is shown in the figure. Sketch the graph of a given equation. We're definitely not going to do all these. But here's f of x. So how would I do part A? X minus 2. Which way would the graph shift? To the right 2 units. You go 1, 2. And that'd be your answer. That's not very difficult, is it? What about C? If you had x minus 2 and you started right here, oh, wrong one. If you started right here again, and you did x minus 2, which way would it go? Down 2 units. 1, 2. No. Just give them a shot. I mean, if you don't know what's going on, sure, check them. I'm not going to ask you to do A through L for a homework check. On a test, I'll just ask you one question. So practice until you get the hang of it. Now, some of them might be a little bit more difficult, like, ooh, the negative 1/2. Let's take a look at that one. That's a cool one. Negative 1/2 of f of x. What's the negative going to do? Flip it over what? X-axis. So we're going to flip it up and down. There we go. There's the negative. Now what's the 1/2 do? Compresses it by factor of 2. So all my peaks would be right here. So my new answer would be, oh, I got confused. There we go. That wasn't on my original curve. So this would be negative 1/2. There we go. Of f of x. I like that. Pretty nifty. I did. Half of 2 is 1. Okay. It's half the size. All right. So I think we got that pretty well. The graph of the function is showing use the properties, write your answer. Okay. I think we got this. The original graph is this one. That's my original graph. Plain as red. All right. I'll use the red. All right, so how do I get the answer in part A first? What do I have to do with the graph in red to get over to A? Move it over 2. 1, 2, and then what? Up 1, up 2. So you write the answer, f of x minus 2 plus 2. Okay? Fantastic. Hopefully it is. How about if we're going to B? B is right here. Yeah, you're just going to flip it, right? So y equals negative f of x. Just flips the graph. Then what about C? Let's see if I flip it. This thing actually does have flip. There we go. And then to get C, I'll take the graph in green. And what do I have to do first? Somebody said over 1, 2, 3. One more? 4. And flip it. Flip it. And then what? 1, 2. So I moved it over how far? F of x minus the negative 4 makes it plus 4. Then I flipped it, and I moved it up how far? 2. Okay? That's not so bad. It's going to be really hard to get like multiplying, like stretching and compressing. It's going to be really hard to do that. Okay? All right. Oh, I love this so much. It's going to be on your homework check and on your test. This is a graph of a piecewise function. You have to put 3 pieces together to make one complex picture. The complex picture is fun. Can you do this on your graphing calculator? No. So, well, because it's too hard to type in the code. Well, if you knew all the codes, even then you wouldn't get the right looking graph. You'd have your resolution all wrong. Negative 2x, is that the equation of a line, a parabola, or a constant? Line, does the line go uphill or downhill? Downhill. That's a downhill line. X squared, what's that look like? A parabola. That opens up, correct? Because A is positive. And negative 2, what's that graph look like? A constant. Just like that. Okay? I have to put all 3 of those together to come up with one graph on here. Well, negative 2x. Oh, I don't want that with it. I'm going to erase that part. Here we go. We'll take it over here. There's the line right there. Negative 2x. What's this part on the right have to do with anything? That's the domain. It says the line is only good for all x's less than negative 1. It's not good for anything past that. It's only good. Oh, so my real answer would be if I went to negative 1 and put it in the equation, I'd get out 2, wouldn't I? There. Negative 1, 2. I put negative 1 in for y. I got out 2. Negative 1, 2. Oh, now I got to put this equation in there. How do I know where it goes? Can't go anywhere? Can't just go anywhere I want. What? Any way I want. Which way? The domain. The domain tells me that on my graph, I can only have, I can't have all the points. I can only have the points negative 1. If I put it in there, I get out 1, don't I? With a closed circle. And my other point would be 1, 1 with an open circle. How do you know if it's open or closed? Is there a line? Is there a line? Negative 1, 1. Closed, 1, 1, open. And what's it going to look like from dot to dot? Is it going to be a straight line? No, it's going to have this little parabola in it. This cute little parabola, just like that. Nice. And this line right here, students, I don't know what is wrong with them. They do this. Oh, that's negative 2. I know that one. I was awake that day. And they take their graph. Ooh, wrong one. They put it on here and they say, we're done. Is that a function? Does your picture pass the vertical line test? No, it doesn't. This graph doesn't start until x is bigger than 1. So the graph doesn't even start until you get on this side of it. It doesn't start until you get right here with a closed dot. And somebody goes, well, why, how come you have to have a closed and an open? How come they both can't be closed? If they were both closed, it wouldn't pass the vertical line test. It wouldn't be a function. It says draw the graph of f. It says f is a function. Okay? That's the picture. Why is it called a piecewise function? You have 3 pieces. You have a line with some slope. You have a parabola with a curved line. You have a constant function. The domain tells you which pieces of the graph you're going to use. For this line, I only use this part of the graph from here on. For this parabola, I cut it off. I only use this part. And for this line, I cut it off. So you're cutting off sections of graphs to make one unique picture. Piecewise functions are how the world actually moves. This is the greatest integer function. I don't do a lot with it. How much time I got? Okay. I would skip that if you got the greatest integer function. If you want to graph it out, go ahead. It's INT on your calculators under math and number. Yeah. I don't do a lot with greatest integer function. Never really known anybody to do, actually, but at least you know what it means now. INT under math. You go to graph y equals math number INT parentheses x plus 2. I guess I could take a look at it. It's not that big a deal. It is.
So cool.
Yeah, it's not that big a deal. The main thing about it is you see it. Math, number, INT, and I'll graph out this one. X. Now some calculators will have lines connecting the steps, some won't. Just depends on your make and model. Okay? It's not that big a deal on the graph. It shows up in calculus here and there, but that's about it. Okay? Hey, what would 1/2 x do to it? Would it widen the steps or shorten the steps? Widen the steps. Let's see. Second insert. I'm going to widen them by a factor of 5. 1 divided by 5 times x. Whole wide steps. Congratulations, that's your first step in graphic design. That's what you do. You take things and you change it. You change the parameters of the picture to come up with something you want. It's not that difficult. Huh? Yeah, there you go, see? Oh, never mind. That caused too many hard feelings when I did that. All right. Last but certainly not least. Perfect. A certain sales is taxed on the first 500,000 property value at a rate of 1%. This is for all the people that are going to pay property taxes in their lifetime. So pretty much everybody, except for Michelle. All right. Find a piecewise function. I'll call mine t of x. I'll show you how the first one works. If your home is worth $400,000, you'll pay 1%. And then that is taken and put through another equation. So they take 1% of that and they run it through an equation. You don't pay 1% of that, you pay something else. But anyway, so for x, you're going to multiply it by 1%. There is no percent key on the calculator, so you write it as 0.01. If x is less than or equal to 500,000, and it's bigger than 0. You have to put the bigger than 0 because you can have negative property value. You can, but we're not in that game right now. That's another game for another class. So, over 500,000, you're taxed at a rate of 1.25%. That's if x is greater than 500,000. However, the first 500,000 is still taxed at 1%. How would you account for that in your second equation? The first 500,000 is still taxed at 1%, not the 1.25. So if your home is worth $600,000, you're only going to pay tax on 1.25% of the 100,000. Does that make sense? So if x is 600,000, 500,000 is paid on 1%, right? 500,000 is paid at 1% plus x minus 500,000 paid at 1.25%. The answer is going to be different in the back of the book. I wanted you to see where the numbers came from. They multiplied it out and combined like terms. Okay? Fantastic. For your homework check, I want you to take out a sheet of paper. You can use an old sheet if you like. And on page 150, I think it's page 150, should be section 2.4, 7F, 18, 23, 47, and 50. I know, that's my favorite question. Favorite question of the day is 7F. Yep. I did. All right. Let me turn this off, and I'll get the papers. There's only 20 minutes. Oh, we did homework questions. Okay.